Good morning, everyone. My name is Jongbok Lee. I am the professor of Hansung University in Seoul, Korea. I'm very pleased to present my paper in CSCE 2021. The title of the paper is Revisiting the Out-of-Order Superscalar Processor Core. The out-of-order superscalar processor core is the basic building block of the current multi-core processors. A superscalar processor core is proposed with a modified register status unit of Tomasillo algorithm, a sophisticated utilization of which the record type and their round-robin connection scheme has to maintain consistency among reservation stations, reorder buffer, and register status is addressed. Figure 1 shows the out-of-order superscalar processor core. Like a traditional Tomasillo algorithm machine, it consists of reservation stations, a reorder buffer, integer function units, a low-store memory unit, a multiplier, and a branch unit. In the design, 6-stage instruction pipeline, which consists of fetch, issue, execute, memory access, write-back, commit, is employed. The key idea of this paper is the modified register status bit. The register status bits are extended to the 4 values of 0, 1, 2, and 3. The bit values of 0 and 1 is used when the source and the destination registers are different, as in the original scheme. However, for the instruction and the following instructions which have the same destination and the source register, the bit value of 2 and 3 are utilized. The bit value of 2 is used when the destination register and the source register are identical, but still available to be read for the source registers. The bit value of 3 is used when the source register references the register of which its register status bit is 2 and is different from the destination register. As shown in the figure 2, this is the situation for the instructions such as sub as R5, R1, R3, which follows sub R1, R1, 8. In summary, the data is available when the register bit is 0 or 2, but unavailable when it is 1 or 3. When the instruction of which its destination register bit value of 1 or 2 or 3 is executed, it is updated to 0 eventually. By applying this scheme, the register renaming can be more effectively implemented for the out-of-order superscalar processor core. Figure 3 is the declaration of the record data structure of VHDL used in the design as a package statement. The single record type of the reservation stations and the reorder buffers are defined as TY reserve and TY ROB respectively. After declaring the reorder buffer and the reservation station as a record type array, the VHDL for loops are used when searching for a record type that meets the conditions. In each VHDL model, by declaring a record array as an input or output as an entity statement port, information can be efficiently exchanged between different models in a record array unit. As shown in the figure 5, the data structure of the reservation station, the reorder buffer, and the register status unit is composed of 6 stages of the pipeline, and the data of the previous stage is transferred to the data of the next stage every cycle. For instance, ROBF, ROBI, ROBE, ROBM, ROBW, ROBC corresponds to the fetch, issue, execute, memory access, write back, and commit of the reorder buffer data structure respectively. When the data traversing each stage reaches the end, the final commit stage is fed back to the first fetch stage in a round-robin fashion and transfers data downward as to maintain the consistency. Figure 6 presents the simulation results of running the out-of-order superscalar processor core. The input program consists of several loads, stores integer instructions, and branches. After performing the simulation and checking the data values recorded in the register file and the data memory of the superscalar processor, It is confirmed that the fully pipelined two-way out-of-order superscalar processor executes correctly. As a conclusion of this study, a fully pipelined out-of-order superscalar processor based on the modified register status unit of Tomasulo algorithm is proposed. By introducing 0 to 3 busy bits in the register status unit, the register renaming technique is effectively performed. By designing the reorder buffer, the reservation station, and the register status unit in an array using a record-type data structure, a high level of abstraction and accuracy are secured in the programming language. Thank you very much.